Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here. We're continuing with our Core 1 integration series. This is the second video in this series, and we're going to talk about integration of polynomials and how to actually do that. The first video was what is integration. Now we're doing how to do integration. Okay, to start this off, I'm going to give you four functions, let's say. Y is equal to x squared. I'm going to give you y is equal to x squared take away 1. I'm going to give you y is equal to x squared add 4. And I'm going to give you y is equal to x squared add, let's say, 11. Okay? And in each case, I want you to differentiate them. So let's remember the differentiate rule. So the differentiate rule, remember differentiate. If you are differentiating, okay, something like y is equal to x to the power of n. Okay, what do? Well, dy by dx, you bring down the power n, you keep the x, and you reduce the power by 1. So let's just try and say that in words. So we bring down the power and multiply by the new power and reduce power by 1. Okay, so the first thing we do, we bring down the power and multiply, and the second thing we do, we reduce the power by 1. Okay, so that was differentiation. So let's do that in each of these cases. Dy by dx would actually turn out to be 2x here. What would it turn out to be in this case? What would it turn out to be in this case? What would it turn out to be in this case? Well, because we should remember that any number differentiates to 0, when I differentiate x squared take away 1, I'm going to get 2x add 0, which is just 2x. So this also is going to differentiate to 2x, and this also is going to differentiate to 2x, and this also is going to differentiate to 2x. Now, that causes us a problem, because we know this process going downwards is differentiation. Okay, going from the original function to the differentiated function dy by dx, or the gradient function, is differentiation. And we know the opposite process is called integration, going backwards. But if I told you the function, say if I told you that dy by dx was equal to 2x, what would your y be? Well, it could be x squared, it could be x squared take away 1, it could be x squared add 4, it could be x squared add 11. In fact, it could be x squared plus any constant. So it would be x squared plus this constant. And you will always have this when you integrate. You will always have a constant of integration, and you must always include it, because we know that going backwards, differentiating this, the constant always disappears. So when you integrate, you must always introduce a constant of integration, and if you don't, you have made a mistake, which you'll lose a mark for in the exam. Okay, so because here all the 2x's, they could integrate back to any of these, we always have to add a constant of integration, which we may or may not have to find out in the question. Okay, so that's the first thing, and we'll see examples of that. So that's the first thing. The second thing is just the rule for polynomials. Now, polynomials, you'll remember from one of the first videos, polynomials are just things like y equals x cubed add 3x squared, things like that. X to a power, so they're that type of thing. Now, let's just remind ourselves of differentiation again for the second time in this video, so we're absolutely sure. Differentiation. So if we have something like y is equal to ax to the power of n, a is just a number, then dy by dx is nax to the n minus 1. And we said in the previous video, what do? Well, the first thing is bring down power plus multiply. That was step 1. And step 2, reduce power by That's step 2. Now, integration is the opposite process. I'm going to do this in red. Integration. Suppose we had some function and it was of the form, it's not the same function. Suppose we had some function, I don't know, dy by dx is equal to some different number, let's say bx to the power of m, some different power. Let's do it back. If we first bring down the power and multiply and then reduce the power by 1, going backwards, doing the opposite, the first thing we should do is increase the power by 1. That's the first thing we should do. And secondly, what should we do? What's the opposite to bringing down the power and multiplying? It's to divide by new power. Step 2. Okay, so going backwards, if this was dy by dx, then y would be equal to, the first thing is increase the power by 1, x to the m plus 1, you would increase it by 1, okay? And the next thing you would do is you would divide by that new power. Now I've got a b there already, that b's got to stay. I would divide by the new power, m plus 1, that I've got. Okay? So let me give you a particular example. Suppose dy by dx was equal to, let's say, something like 5x to the power of 2, let's say. If I was integrating this, the first thing I do, so I'm going to integrate both sides. I'm going to put a dx there and a dx there. On this side, I'm going to get y back, my original function, after I've integrated dy by dx. Now on this side, let's think about it. I increase the power by 1, so I'm going to have x cubed, and then I divide by that 3. Now I've already got a 5 there, don't forget about your 5 there. Keep the 5, but divide by 3. And don't forget, we always must add a constant of integration plus c. So integration, increase the power by 1, divide by the new power. Now we're going to do several examples so you get the hang of this. So let's have a go at the first one. Find y for the following. dy by dx is equal to x to the power of 4. So I'm going to write down dy by dx, I'm going to give plenty of space, equals x to the power of 4. I've got the gradient function, I want to find the original, so I'm going to integrate both sides with respect to x. I'm going to integrate that side with respect to x, and I'm going to find out the answer. When I integrate dy by dx, the gradient function, I get y. I'm always going to get y on this side. Now, is equal to, increase the power by 1, x to the power of 5, and divide by the 5. Now, I like writing it like this. There's a hidden 1 there, always a hidden 1. I like writing it as a fifth x to the power of 5. Okay, so that's a fifth x to the power of 5, and you must always add plus c, your constant of integration. And that there is done. Now, if we wanted to make sure we hadn't made a mistake, you could differentiate this and check you got x to the 4 back. A constant differentiates to 0, we know that. And if I differentiate this, if I put down the 5, I'd get 5 over 5, which is just 1. Reduce the power by 1, I'd get 4. I get x to the power of 4. So you can check by differentiating your answer. Differentiating your answer. And we're always going to do a quick sense check for that. Okay, next example. Find y if dy by dx is this. So I'm going to give myself plenty of space. So let's have a look. Dy by dx equals x to the power of negative 5. To get my y back, I'm going to integrate this side with respect to x. I'm going to integrate this side with respect to x. I'm always going to get y on this side. And on this side, increase the power by 1. So I'm going to have x to the power of negative 4 and divide by negative 4. Now there's a hidden 1 there. I'm going to divide by negative 4. And don't forget my constant of integration plus c. Now I might tidy this up. 1 divided by negative 4 is just negative quarter. So I'll rewrite this as y equals negative a quarter, x to the power of negative 4 plus c. If I differentiate this, if I brought down the negative quarter, I get 1 x to the power of negative 5. C differentiates to 0. I would have got my original back. So I know it's right. Okay, next one. dy by dx is 2x cubed. Let's integrate. So given us a plenty of space, dy by dx is equal to 2x cubed. I'm going to integrate both sides with respect to x, integrate this side with respect to x, and then what I'm going to do, this side I'm clearly going to get y like I always do. This side, add 1 to the power, so keep the 2 there, add 1 to the power, make it 4, divide by that 4, we'll just divide the 2 by the 4, that was the same thing, and add your constant. But you must simplify your fractions. 2 divided by 4 is a quarter. So y is, a half. So y is a half x to the power of 4 plus c. If we did differentiate this back, if I differentiate this, I'd get dy by dx. If I differentiate this, bring down the 4, 4 times a half is 2, sorted, and we'd reduce the power, I'd get x cubed. C differentiates to 0. This all works. Dy by dx is 3x to the power of a half. So dy by dx, big gap, 3x to the power of a half. To find my y back, they're asking me to find y. I'm going to integrate this side with respect to x. I'm going to integrate this side with respect to x. I know I'm always going to get y on this side, so y is equal to. Now this side, let's just think about it. I'm going to increase the power by 1. That's going to be x to the 3 over 2. I'm going to divide by the new power, 3 over 2. So 3 divided by 3 over 2. Okay? And don't forget, I've got my plus c. Now, you may want to do working for this. Go over here and do a separate working. What's 3 divided by 3 over 2? Let's write it like this. 3 divided by 3 over 2. Now 3 is really 3 over 1 divided by 3 over 2, which is 3 over 1 times 2/3, which is equal to 6 over 3, which is 2. So 3 divided by 3 over 2 is 2. Another way of doing it, you could have just asked yourself how many 1/2s go into 3, and the answer is 2. So y is therefore equal to 3 divided by 3 over 2, which is 2, x to the 3 over 2 plus c. Now let's check if we differentiate this back, I'd get this. If I differentiate y, I get dy by dx. If I differentiate c, I get 0. If I differentiate this, bring down the 3 over 2, 3 over 2 times 2 is 3, hence the 3. And if I reduce the power by 1, I would get x to the half. So this is definitely right, and that is my final answer. So that's an introduction into the constant of integration and how to do integration in basic cases. Hope you found that useful and it made sense. Thanks for watching.